Okay, here comes the next example. We'll do two more. Now, but these two times, the curve actually got small enough, fast enough, that it actually converged, either to 1 over 20 or 4. It will not always converge, as we will see in this example. So we want to find the integral from 0 to 8, from 0 to infinity, sideways 8, of 2 divided by 8 plus x, and we set that up the same way we set all of them up. We replace infinity with a b, and we take the limit as b goes to infinity of 0 to b of 2 over 8 plus x dx. So that is allowed. We're taking the limit as b goes to infinity of this integral. And if you'll remember, this integral is actually simply the limit as b goes to infinity of 2 times the natural log of 8 plus x. So notice that if we remember that the derivative of the natural log is 1 over x. So if I take the derivative of this, I'll get the derivative of this is 2 over 8 plus x. And luckily this term is just 8 plus x, which means we do not need to worry about chain rule or anything like that. So we're good to go. So if I go ahead and evaluate this, this will be the limit as b goes to infinity of 2 natural logs 8 plus b minus 2 natural logs 8 plus 0. Okay, and you could just write that as 8 if you want. And here we've run into a little bit of a snag. And that's because the natural log function looks like this. I'm sorry, natural log's never negative, excuse me. So the natural, forget this little bit down here, the natural log curve looks like this, and although it gets flatter and flatter and flatter as it goes off to infinity, infinity is a really long time, and this curve will always keep going up, 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 up. So as this curve, as b goes to infinity, as this curve continues on forever, this will go to infinity. So there's several ways to say that. You can say it diverges, meaning it does not converge to any number, or it approaches infinity, or the limit does not exist. All of these are different flavors of the same idea. This infinite integral diverges. It does not get small enough fast enough, and so it diverges. However, you need to put that into your homework. Any questions about that, please send me an email. Let's go ahead and do one more example before we wrap up this video. Here we have a company determines that its marginal cost in dollars for producing X units of a product is given by this. Here's the marginal cost. Suppose that it were possible for the company to make infinitely many units of this product. What would the total cost be? Now that sounds kind of silly, that it would produce an infinite amount of product, but these curves are actually useful because there is such a thing as economy of scale. You know, you might start a business selling soap, then you sell enough soap that you can build a robot that makes the soap for you, and pretty soon you can make it cheaper and cheaper and cheaper as you make more and more and more soap. That's one of the ways that the market gets better and society evolves and improves. So anyway, let's go ahead and do this. We need to take the integral from 0 to, we're starting at one product. So we're taking the integral from 1 to infinity of the marginal cost. And so there is our setup. That's our setup for doing this problem. And like the past, like the past examples, we can replace that with the limit as b goes to infinity of 1 to b. And this becomes 4100 x to the negative 1.5 dx. Happy, happy, happy. Now we're just ready to take the integral. So we know that this will be the limit as b approaches infinity. Now, this will be 4100 x to the negative 0.5, and this will be evaluated from 1 to b. So we know that the 0.5 fell to 1.5, the negative 0.5 fell to negative 1.5. So let's think about how that would have affected this. If we were to take the derivative of this, we would multiply by this and then drop it by 1. So what that means is we need to divide it by negative 0.5. And that's literally how my brain processes these integrals. I kind of half complete it and then see what changes I need to make. And luckily, the ones on your homework are not so difficult that you need to use the chain rule, I don't believe. If there's any you get stuck on, please send me an email. This will be the limit as b goes to infinity. Let's clean this up. Dividing by a half is the same thing as timesing by 2. So this will be negative 8200 b to the negative 0.5. Then it'll be minus, which turns into a plus because of that minus. That'll be 8200 b to the negative 0.5. So I skipped a couple steps right there. If you have a question, please email me. Basically, this is dividing by a half, which is the same thing as multiplying by 2. So that's how the 4100 became 8200. The x got replaced by b, and this first one was negative, and then when we evaluated it, we needed to subtract this negative, which then turns this into a plus. And I actually made a mistake right here. This should be a 1 right here, because we put in the b and then we put in the 1. All right, before we take the limit, let's rewrite this. So this will be negative 8200 divided by b to the half, which is the same thing as b to the square root, plus 8200 divided by 1 to the 0.5, which is the same thing as the square root of 1. All right, so now we activate the limit. The limit gets activated. This will always approach 0 forever. And so this is just 8200 divided by the square root of 1, which is just 8200 divided by 1. So our final answer, which is the correct one, is $8,200. So that would be the total cost if you could produce an infinite number of goods, assuming that's the marginal cost, meaning the cost to make the next item. If that shrunk fast enough, you would have a total cost to produce as many as you wanted, which may or may not be reasonable. It's becoming more reasonable as we start to invent more sophisticated robots that need very little maintenance. All right, sorry I messed up that b to a 1 right there. If you have any questions on this, please send me an email. I think that's enough examples for this section, so I will see you in the next section.